This is the first video for our integration series of videos. So the first one says integration as the reverse process of differentiation. So let's try to review for a while some of the concept that we had in differentiation before. So let's say that my y is equal to 3x squared. So my dy dx is equal to 6x, right? And if I have, for example, y is equal to 3x squared plus 1, my dy dx is also equal to 6x. If I have, for example, my y is equal to 3x squared minus 1, our dy dx is also equal to 6x. So as you can see, there are infinite number of questions in this form with only one derivative. If you are taking from the y going this way, that is differentiation. However, if you are taking the reverse operation, the question is the dy dx, and you are looking for this for the y, that is integration. So that is integration. Okay? How do we do that one? So conceptually, if you have the integral of the dy dx is equal to 6x, you can actually separate that dy and dx and just make it 6x dx. Take the integral of both sides. So the integral of dy, what we expect is that the integral of this is this one. So the answer to that is y is equal to the integral of 6x. Our expectation is this one because they're just the reverse process. So that is equal to 3x squared. However, we have a problem because if you take the integral of 6x, there is only one answer. Y is equal to 3x squared. But then as you can see from here, these three questions have the same derivative. So therefore, what do we need to do is that we need to add plus c, wherein this c is what we call as arbitrary constant. It is arbitrary constant because it is a constant that based into some specific condition. Okay? So later on in the next part of this video, we're going to discuss that one on the next topic. Right? Now, however, again, the integration is the reverse of derivative, or the derivative is the reverse of integration. And it is very useful for us to be able to use the following formulas. So you need to remember these formulas because these are the basic integration formula. Number one, the integral of x to the n dx is equal to this one. And of course, do not forget your plus c. Okay? Number two, what about if there is an a x to the n? According to this one, you can put the a outside the integral and take the integral of inside of x to the n, which you will have this. And the integral of a number a with respect to x is equal to ax. Again, don't forget the plus c. Okay, plus c. So let's try to have some example. I will label this formula number 1, 2, and 3. Let us start with formula number 3 because that is the most simple one. Okay, formula number 3. Formula number 3 says the integral of any constant is equal to ax plus c. Example, the integral of 0.1 dx, that's 0.1x plus c. Okay, just put the x. The integral of 1/2 dx, that is equal to 1/2 x plus c. The integral, for example, of 3 dx, that is equal to the integral of 3x plus c. The integral of square root of 2 dx, that is equal to the square root of 2 times x plus c. So basically what we're trying to say, what does this formula says is that any constant, for you to be able to get the integral, just affix x beside it and you add the plus c. Alright? Now let's try to look at this formula number 1. The formula number 1 is very simple. It says the integral of x to the n dx is equal to x to the n plus 1 over n plus 1 plus c. Let's try to have an example. The integral of x to the 4th dx. Our n here, take a look that our n here is your 4. And what does it say? That is equal to the x to the 4 plus 1, because n plus 1, over 4 plus 1 plus c, which is equal to x to the 5 over 5 plus c. Or if you want to write it this way, that's also correct. Okay? Another example. So let's say that I have the integral of x to the 1/2 dx. So therefore, again, x to the 1/2 plus 1 over 1/2 plus 1, which is equal to x to the 3/2 all over 3 over 2. Then that will be equal to 2 over 3 x raised to 3 over 2 plus c. Okay? So again, how come that's 2 over 3? Because remember, for example, if you have, for example, a over b divided by c over d, so to divide, that's a over b times d over c. You take the reverse, and this one here is division. Let's try to have one more example. Suppose you have the integral of x to the 0.1 dx. Again, it says x to the 0.1 plus 1 all over 0.1 plus 1, which is equal to x to the 1.1 all over 1.1 plus c. Then just in 1.1, why did I write 1.5? Okay, 1.1 plus c. Now, what is the second formula? This second formula here. The second formula says the integral of a x to the n dx. Either you put the a outside the bracket, the integration symbol, and take the integral of that part, which we all know. So therefore, that is a x to the n plus 1 all over n plus 1, and then just put plus c. Let's try to have some example. Suppose I have the integral of 3x to the 4th dx. Again, it says you can put the 3, think of 3 as outside, so 3, the integral of x to the 4th dx. Then you apply the formula number 1. So you have there 3x to the 4 plus 1 over 4 plus 1 plus c, or equal now to 3 over 5x to the 5 plus c. Now, what about if we combine all of this? So let's say, for example, my question is, find the integral of 3x cubed minus 4x squared plus 2x minus 1 with respect to x. Again, you just need to apply the formula on each term. So for the first term, you will have there the answer as 3x raised to the 3 plus 1 over 3 plus 1 minus 4x to the 2 plus 1 over 2 plus 1 plus 2x to the 1 plus 1 over 1 plus 1. And that's a constant, so minus x, and don't forget your plus c. Then let's just try to simplify this. So that will be 3 over 4 x raised to the 4 minus 4 over 3 x raised to cube plus 2 over 2 is 1, so x is squared minus x plus c. So this is now your answer. Okay, so that's what you're going to do for this type of questions. Alright, so that's the end for this video. Have a good day and see you on part 2 of this.